Welcome to the video. Good day, ladies and gentlemen. I'm Alita Angelita and I'm one of the reporters for today's video lesson. Together with my co-reporters, we will be talking about double angle identity. A quick outline of what our video will consist of. We will be discussing the definition of double angle identity, sine double angle formula, cosine double angle formula, and tan double angle formula, all of which will have their own examples. So, what is double angle identity? Double angle means that we increase the given angle by 2 and find the sine, cosine, or tangent, or most commonly known as sin cos tan of twice the given angle. Double angle formula is a trigonometric formula, and the reason why they are called this is because they involve trigonometric functions of double angles, that is, sin 2a, cos 2a, and tan 2a. We can use this identity to rewrite expressions or solve problems. Basically, these are trig identities that demonstrate how to calculate the sine, cosine, or tangent of a given angle twice. Moving on, let's now talk about the sin double angle formula, which is the first formula of the three basic double angle formulas. To calculate the double angle 2 theta of sine in terms of the original angle theta, we use the formula sine 2 theta is equal to 2 sine theta cosine theta. You can derive this formula from the angle sum identity, as the sum of two sines is sine alpha plus beta is equal to sine alpha cosine beta plus cosine alpha sine beta. Sine theta plus theta is equal to sine theta cosine theta plus cosine theta sine theta. That is how we got sine 2 theta equal to sine theta cosine theta. An example using this formula will be given and discussed later after we give all the three formulas.
Hello everyone, I'm class number 2 of Math Authentico, and I will be sharing the three forms of the identity for cosine 2 theta of the cosine double angle formula. The three forms of the identity for cosine 2 theta is cosine squared theta minus sine squared theta, 2 cosine squared theta minus 1, and 1 minus 2 sine squared theta. You can derive the first formula from angle sum and difference identities. Sine alpha plus beta is equals to sine alpha cosine beta plus cosine alpha sine beta. Sine alpha plus beta is going to become sine theta plus theta, and that's equals to cosine theta cosine theta minus sine theta sine theta. Cosine 2 theta is equals to cosine squared theta minus sine squared theta. The other two formulas were derived from the well-known Pythagorean trigonometric identity, sine squared theta plus cosine squared theta is equals to 1. To get the second formula, we have to replace sine squared theta by 1 minus cosine squared theta. So cosine 2 theta is equals to cosine squared theta minus sine squared theta. Cosine squared theta minus 1 minus cosine squared theta, and cosine 2 theta is equals to 2 cosine squared theta minus 1. To get the third formula, we have to replace cosine squared theta by 1 minus sine squared theta. Cosine 2 theta is equal to cosine squared theta minus sine squared theta. 1 minus sine squared theta minus sine squared theta. So cosine 2 theta is equals to 1 minus 2 sine squared theta.
Hi everyone, I am Shane Ponce, the third reporter for this video lesson. Next we have is the tangent double angle formula. The formula for the tangent of a double angle looks as follows. Tangent 2 theta is equal to 2 tangent theta divided by 1 minus tangent squared theta. And this formula is from the sum of tangent formula, which is tangent alpha plus beta is equal to tangent alpha plus tangent beta divided by 1 minus tangent beta tangent alpha. With this formula, we're going to find the theta. So it will be tangent theta plus theta is equal to tangent theta plus tangent theta over 1 minus tangent theta tangent theta. Thus, our double angle formula would be tangent 2 theta is equal to 2 tangent theta over 1 minus tangent squared theta.
Example number 1. If sine theta is equals to 5 over 13 and theta is in quadrant 2, find sine 2 theta, cosine 2 theta, and tangent 2 theta. The formula there is cosine squared theta plus sine squared theta is equals to 1. Cosine squared theta plus the value of our sine theta, which is 5 over 13 squared, is equals to 1. Cosine squared theta plus 25 over 169 is equals to 1. Cosine squared theta is equals to 144 over 169. Cosine theta is equals to positive negative 12 over 13. But since our theta is in quadrant 2, it's going to be negative 12 over 13. So the value of our cosine theta is equals to negative 12 over 13. To find sine 2 theta, we'll use the formula 2 sine theta cosine theta. So that's 2 times 5 over 13 times negative 12 over 13. If we simplify that, sine 2 theta is equals to negative 120 over 169. As for our cosine, the formula is cosine squared theta minus sine squared theta. So that's equals to negative 12 over 13 squared minus 5 over 13 squared. That's equals to 144 minus 25 over 169. So our cosine 2 theta is equals to 119 over 169. To find our tangent 2 theta, we'll use the formula of 2 tangent theta over 1 minus tangent squared theta. But first, we have to look for the value of our tangent theta. The formula is sine theta over cosine theta, which is why we have the values of 5 over 13 and negative 12 over 13. If we will simplify that, we'll get the answer of negative 5 over 12. So now that we have our values, it's time to substitute. 2 times negative 5 over 12 over 1 minus negative 5 over 12 squared. That's equals to negative 5 over 6 over 1 minus 25 over 144. That's equals to negative 5 over 6 over 119 over 144. That's equals to negative 5 over 6 times 144 over 119. So our tangent 2 theta is equals to negative 120 over 119. Example number 2, find cosine 4 theta. Cosine 4 theta could also be written as cosine 2 theta plus 2 theta. So cosine 2 theta minus sine 2 theta is equals to cosine squared 2 theta minus sine squared 2 theta. So that's equals to 2 cosine squared theta minus 1 squared minus 2 sine theta cosine theta squared. It's equals to 4 cosine to the power of 4 theta minus 4 cosine squared theta plus 1 minus 4 sine squared theta cosine squared theta. That's equals to 4 cosine to the power of 4 theta minus 4 cosine squared theta plus 1 minus 4 times 1 minus cosine squared theta cosine squared theta. That's equals to 4 cosine to the power of 4 theta minus 4 cosine squared theta plus 1 minus 4 cosine squared theta plus 4 cosine to the power of 4 theta. And that's equals to 8 cosine to the power of 4 theta minus 8 cosine squared theta plus 1.
Example number 3. If cotangent theta is equal to 4 over 3 and theta is an acute angle, find the exact value of tangent to theta. So for this problem, we are going to use the tangent double angle formula, which is tangent 2 theta is equal to 2 tangent theta divided by 1 minus tangent squared theta. To get our value of tangent theta, we are going to get the reciprocal of cotangent theta. Our cotangent theta is 4 over 3. The reciprocal of 4 over 3 is 3 over 4. So our tangent theta is 3 over 4. We're going to substitute it. It would be 2 times 3 over 4 divided by 1 minus 3 over 4 squared. 2 times 3 over 4 is 3 over 2. And 3 over 4 squared is 9 over 16. Then we're going to solve it. So copy 3 over 2 and then subtract 1 to 9 over 16. So 1 minus 9 over 16 is 7 over 16. Then our answer will be 3 over 2 divided by 7 over 16. And in order to multiply it, we're going to get the reciprocal of our denominator, which is 7 over 16. So the reciprocal of this 7 over 16 is 16 over 7. Then we're going to multiply it. So 3 over 2 multiplied by 16 over 7 is 24 over 7. So our tangent to theta is 24 over 7. Lastly, we have example number 4. Find the exact value of cosine to theta given that cosine theta is equal to negative 13 over 14 if theta is in the second quadrant. So for this problem, we're going to use the cosine double angle formula. And since there are 3, we're going to choose only 1. And that formula is cosine 2 theta equals 2 cosine squared theta minus 1. And since we already have our value for cosine theta, we're just going to substitute that. So 2 times negative 13 over 14 squared minus 1. Since cosine theta is equal to negative 13 over 14. The negative 13 over 14 squared is 169 over 196. So our equation will be 2 multiplied by 169 over 196 minus 1. And then 2 multiplied by 169 over 196 is 338 over 196. Then our equation will be 338 over 196 minus 1. In order to subtract that, we're going to subtract it by the common denominator, which is 196. So 338 over 196 minus 196 over 196. And the answer for that is 142 over 196. And we're going to divide it by 2 to reduce it. Then it would be 71 over 98. Therefore, our cosine 2 theta is equal to 71 over 98.
That is all for the report. If you have any questions, please do not hesitate to ask.